There are places where stone refuses to surrender its secrets, where the past whispers questions we still cannot answer. Ancient Greece was not just the birthplace of ideas, but of builders whose work still challenges modern minds. These are not ruins, but mysteries in stone, and the deeper we look, the stranger it becomes. Revealing knowledge we are only beginning to question. Stand before the Antikythera mechanism's home island, and you realize something unsettling. Before this corroded bronze device was pulled from a shipwreck in 1901, we had no idea the ancient Greeks possessed anything remotely like it. Inside that crusty mass of gears was a computer, a genuine astronomical calculator from around 100 BCE, that tracked celestial movements with frightening accuracy. It predicted eclipses, mapped the irregular orbit of the moon, and even followed the 4-year cycle of the Olympic Games. But here's what keeps researchers awake at night. The technology to build something this sophisticated shouldn't resurface for another 1,500 years. The gears are cut with a precision that demands tools we have no evidence the Greeks possessed. No texts describe it. No other examples exist. It's as if someone dropped a piece of alien technology into ancient waters and hoped nobody would notice. Except we did notice, and we still can't explain where this knowledge came from or where it went. The Temple of Apollo at Delphi sits on a geological fault line that releases ethylene gas, a known hallucinogen. That part we understand now. What we don't understand is how the ancient Greeks identified this exact spot without seismographs, gas detectors, or modern geology. The Oracle of Delphi wasn't placed randomly on a mountainside. She sat directly above a chasm where gases seeped through cracks in the limestone, inducing the trance states that made her prophecies legendary. But the temple's construction reveals something even stranger. The blocks fit together with earthquake-resistant techniques that modern architects only rediscovered in the 20th century. The building has survived millennia of seismic activity in one of the most geologically volatile regions of Greece. Engineers have studied the interlocking stones, the deliberate gaps that allow movement, the foundation design that flexes rather than shatters. The Greeks built this temple to dance with earthquakes, not fight them. How did they know? What previous disasters taught them these techniques, and why didn't they write any of it down? The Colossus of Rhodes stood over 100 feet tall, making it one of the 7 wonders of the ancient world. For 56 years, it watched over the harbor before an earthquake brought it down in 226 BCE. Here's the problem. We have no blueprints, no construction records, no surviving documentation explaining how it was built. Ancient accounts tell us it took 12 years to complete and required an iron framework, bronze plates, and stone reinforcements. But the mathematics involved in creating a statue that massive, that balanced, that structurally sound, they're staggering. Modern attempts to reconstruct the engineering have produced dozens of conflicting theories. Some say it straddled the harbor entrance. Others insist that's physically impossible. Recent scholarship suggests it stood on a hill overlooking the port, but even that placement raises questions about foundation stability and wind resistance. The statue's remains lay on the ground for over 800 years before being sold for scrap, and with them went any chance of understanding the construction secrets. What we're left with are fragments of descriptions and a nagging question. If building something like this was possible in 280 BCE, what else were they capable of that we've completely forgotten? Deep beneath Athens lies the Tunnel of Eupalinos on the island of Samos, and it represents an engineering achievement that borders on the absurd. In the 6th century BCE, workers began digging from both sides of a mountain simultaneously. Think about that. No GPS, no laser guidance, no radio communication. Just 2 teams with picks and hammers carving through solid limestone, somehow destined to meet in the middle. And they did. The tunnel stretches over a kilometer, and the 2 teams missed each other by less than a meter vertically and mere feet horizontally. Modern surveyors using advanced equipment struggle to understand how this was accomplished. The terrain is irregular. The Hoporti mountain isn't uniform. Magnetic compasses didn't exist. Recent studies suggest they may have used water-filled trenches on the surface to establish level sightlines and geometric calculations to plot the path. But even these theories require a level of mathematical sophistication that we thought came much later. The tunnel still functions, water still flows through it, and engineers still can't agree on exactly how it was done. The Theater of Epidaurus holds 14,000 people and possesses acoustic properties that baffle modern sound engineers. A coin dropped in the center of the orchestra can be heard perfectly in the back row, 55 meters away. No electronic amplification, no acoustic panels, just limestone seats arranged in a precise semicircle that somehow creates a natural sound system superior to many modern concert halls. For decades, scientists assumed it was luck, a happy accident of design. Then researchers from Georgia Tech discovered something extraordinary. The limestone seats act as acoustic filters, suppressing low-frequency background noise while amplifying the frequencies of human speech. The corrugated surface of each seat creates a phenomenon called virtual pitch, enhancing the voices of performers through pure physics. But here's the thing, this wasn't an accident. The specific angle of the seating, the material choice, the precise curvature, all of it contributes to the effect. The ancient Greeks didn't have oscilloscopes or acoustic modeling software. They didn't understand sound waves the way we do, yet they built a theater with acoustic engineering that we're only beginning to fully comprehend in the 21st century. Mycenae's Lion Gate isn't just a doorway, it's a statement in stone that we're still trying to translate. The relieving triangle above the entrance holds a limestone slab carved with two lions flanking a central column, and that entire arrangement sits atop a lintel stone that weighs roughly 20 tons. The gateway was built around 1250 BCE during the Late Bronze Age, and it's protected by walls constructed from limestone boulders so massive they're called Cyclopean because later Greeks couldn't believe humans had moved them. Some of these blocks weigh over 20 tons. They're fitted together without mortar, shaped to interlock, and they've stood for over 3 millennia. No cranes, no modern machinery. Recent experiments trying to recreate the construction techniques have yielded mixed results at best. Teams of engineers using every method they can imagine from the period, wooden rollers, rope systems, earthen ramps, struggled to move and position stones even half that size with Bronze Age tools. The precision of the fit, the sophistication of the relieving triangle design to redistribute weight, the sheer audacity of the scale, it all points to construction knowledge that shouldn't exist in an era we consider primitive. And yet there it stands, guarding secrets we've barely begun to excavate. The ancient Agora of Athens contains the Temple of Hephaestus, one of the best preserved Greek temples in existence, and that preservation itself is the mystery. While the Parthenon crumbles and requires constant restoration, the Temple of Hephaestus has remained structurally sound for 2,500 years. It survived wars, earthquakes, occupations, and the ravages of time with minimal damage. Recent analysis reveals a construction technique that reads like a modern engineering manual. The building sits on a 3-step platform designed to distribute weight evenly and resist seismic activity. The columns are slightly inclined inward, creating structural stability through geometry. The entablature features iron clamps set in lead, a sophisticated joinery method that allows for thermal expansion and contraction without cracking the marble. But none of this appears in ancient construction manuals because, and here's the twist, virtually no such manuals exist. The Greeks passed down building knowledge through apprenticeship and practice, not written documentation. So we're left examining a structure that demonstrates advanced understanding of load distribution, material science, and earthquake engineering, built by people who supposedly didn't have the theoretical framework to understand why their techniques worked. They just knew they did. Venture to the island of Delos, and you'll find something that rewrites assumptions about ancient Greek mathematics. The House of Dionysus contains floor mosaics with geometric patterns that use a mathematical principle called aperiodic tiling, patterns that never exactly repeat. For context, Western mathematics didn't formally describe these patterns until the 1970s. A mathematician named Roger Penrose published groundbreaking work on non-periodic tiling, showing how shapes could cover a plane infinitely without the pattern ever repeating identically. It was revolutionary, except the Greeks apparently knew about it 2,000 years earlier. The mosaics on Delos display pentagonal symmetry and quasi-crystalline patterns that shouldn't appear in classical art. Researchers analyzing the tiles found evidence of sophisticated geometric knowledge, including an understanding of irrational numbers and the golden ratio applied in ways that suggest intentional mathematical design rather than aesthetic accident. No ancient texts explain this knowledge. No philosopher claims credit. We simply have these floors, beautiful and mathematically profound, testifying to insights that supposedly didn't exist until the late 20th century. The ancient stadium at Olympia presents a puzzle that goes beyond mere athletics. The starting line, a row of stone grooves where runners place their feet, reveals a starting mechanism that might have been the world's first automated timing system. Recent investigations uncovered evidence of a rope and post system connected to a bronze gate mechanism. When triggered, the gates would drop simultaneously, ensuring a fair start. But analysis of the grooves and post holes suggests something even more sophisticated, a potential timing mechanism that could measure intervals during the race. Scholars are divided. Some insist this is overinterpretation of simple athletic equipment. Others point to the precision of the spacing, the complexity of the gate system, and ancient descriptions of Olympic officials using devices to judge close finishes. We know the Greeks invented the water clock and understood hydraulic principles. We know they valued fair competition with an almost religious fervor. What we don't know is exactly how far their technological innovation went in service of these games. The stadium sits silent, its stones offering hints but never quite revealing the full truth of what happened. When thousands gathered to witness the fastest men in the ancient world compete for an olive wreath, Mount Athos holds monasteries that cling to cliff faces in ways that seem to violate common sense. Built during the Byzantine period but incorporating techniques from classical Greek construction, These structures perch on rock faces hundreds of meters above the sea. The Great Lavra Monastery, founded in 963 CE, features foundation work that extends deep into the mountain itself, anchoring the building to the bedrock. Through a system of stone piers and natural cave integration, what baffles structural engineers is the seismic resilience. This region experiences regular earthquakes, yet these monasteries have endured for over a millennium with minimal earthquake damage. Recent surveys using ground-penetrating radar revealed a construction technique that seems impossibly advanced for the period. The builders created a flexible foundation system that allows the structure to move independently from the cliff face during seismic events, dissipating energy rather than absorbing it. This is a principle modern earthquake engineering embraced in the mid-20th century. How did medieval builders working with Byzantine and classical Greek knowledge implement it without the physics to understand why it worked? The monks who maintain these monasteries speak of divine protection. The engineers who study them speak of genius. The Parthenon isn't straight. Not a single line in the entire structure is truly straight or level, and that's not deterioration. It's intentional design. The columns bulge slightly in the middle, a feature called entasis. The base curves upward at the center. The columns lean inward. Even the spacing between columns varies. This isn't ancient builders making mistakes. This is optical engineering executed in marble. The human eye perceives perfectly straight lines as slightly concave when viewed from a distance. Perfectly level surfaces appear to sag. The architects of the Parthenon understood this perceptual quirk and compensated for it through mathematical precision. The stylobate, the platform on which the columns rest, rises about 6 centimeters at its center along the short sides. Every column tilts inward by about 6 centimeters at its top. These refinements, as scholars call them, required calculations and precision cutting that pushed the boundaries of what we think Bronze Age tools could accomplish. Modern attempts to recreate the curvature using period-appropriate methods have proven extraordinarily difficult. The architects somehow calculated the exact degree of each deviation needed to make the building appear perfect to the human eye. They turned mathematics into illusion, and illusion into timeless beauty. The question that haunts researchers is simple. Who taught them to see like this? The Temple of Zeus at Olympia once housed one of the 7 wonders of the ancient world, a massive gold and ivory statue of Zeus seated on his throne. The statue is long gone, but the temple foundation reveals something that shouldn't be there. Evidence of a precise grid system used in construction that aligns with magnetic north to within a fraction of a degree. Keep in mind, magnetic compasses didn't reach Europe until the 12th century CE. This temple was built in the 5th century BCE. Recent archaeological surveys using differential GPS discovered that the temple's orientation, the spacing of columns, and the placement of interior structures all conform to a mathematical grid of extraordinary precision. The unit of measurement, likely the Olympic foot, was applied with such consistency that variations across the entire structure measure less than a centimeter. This level of precision requires not just skilled craftsmanship, but surveying tools and techniques we have no record of the Greeks possessing. Some researchers suggest they used astronomical observations to establish north, which is plausible. But that still doesn't explain the grid accuracy or the tool precision needed to cut and place stones according to measurements that barely deviate across hundreds of meters. The temple stands as testament to a survey and construction methodology that existed long before we thought such things possible. On the island of Santorini, buried under volcanic ash from one of history's most catastrophic eruptions, lies the ancient settlement of Akrotiri. When archaeologists began excavating in 1967, they uncovered a Bronze Age city with multi-story buildings, sophisticated plumbing, hot and cold running water, and flush toilets. In 1600 BCE, the houses featured indoor bathrooms connected to a drainage system that channeled waste out of the settlement. They had ceramic pipes, stone-built sewers, and even separators that filtered solid waste from liquid. This isn't supposed to exist for another millennium or more. Rome gets credit for advanced plumbing, but the Romans came 1500 years later. What's even more baffling is the engineering sophistication. The plumbing system wasn't primitive. It shows understanding of hydraulics, water pressure, and sanitation that rivals many systems from the medieval period. The buildings themselves rose 3 and 4 stories, supported by timber-reinforced rubble walls and featuring ventilation systems that circulated air naturally. The volcanic eruption preserved everything in ash, creating a time capsule that reveals a level of urban development that rewrites our understanding of Bronze Age civilization. No one knows where this knowledge came from or why it apparently disappeared after Akrotiri's destruction. The city sits frozen in time, its plumbing intact, its secrets buried in ash. The sanctuary of the great gods on Samothrace holds mysteries that go beyond the famous winged victory statue now residing in the Louvre. The sanctuary itself is a complex of buildings designed around secret initiation ceremonies, and its layout suggests acoustic and optical properties that scholars are only beginning to understand. The Enactoron, the Hall of Initiation, features underground chambers with acoustic characteristics that amplify whispers while muffling outside sound, creating an environment where initiates could hear ritual words spoken softly while remaining isolated from external noise. Recent acoustic analysis revealed that the chamber's dimensions create standing wave patterns at specific frequencies, essentially turning the room into a resonance chamber tuned to the human voice. But there's more. The sanctuary's positioning relative to surrounding hills creates sightlines that align with solstice, sunrises, and equinox events, casting light into specific chambers at astronomically significant moments. This requires detailed observation of solar patterns over years, precise surveying to establish alignment, and architectural planning that integrates natural landscape with built environment in ways that suggest a holistic understanding of the site's properties. The initiates who experienced the mysteries of Samothrace were sworn to secrecy, and they kept their oath. We have the buildings, the acoustic chambers, the astronomical alignments, but the knowledge of how all these elements combined to create transformative ritual experiences died with the last initiate. Return to Athens one final time, but go beneath the city to the ancient silver mines of Laurion. Between the 6th and 4th centuries BCE, miners extracted silver from these hills using techniques that modern mining engineers find both brilliant and baffling. The shafts descend over 100 meters into solid rock, following silver veins with accuracy that suggests geological knowledge far beyond simple trial and error. But the real mystery lies in the ventilation. These deep mines required constant airflow to prevent toxic gas buildup and provide oxygen for lamps and workers. The ancient miners created a natural ventilation system using vertical shafts positioned to catch prevailing winds and create pressure differentials that drew fresh air down into the deepest tunnels. This requires understanding of fluid dynamics, air pressure, and local meteorology. Recent studies using computational fluid dynamics models confirm that the ancient shaft placement was nearly optimal for the local wind patterns, as good as or better than modern mine ventilation designs could achieve for the same terrain. They accomplished this without anemometers, without pressure gauges, without any of the tools we consider essential for such engineering. The mines produced the silver that funded Athens' golden age, built the fleet that defeated Persia at Salamis, and made democracy possible. They represent an engineering achievement that powered an entire civilization, and we're only now beginning to understand how brilliant their designers really were. The stones of Greece hold more questions than answers. Each structure we've explored represents not just human achievement, but human mystery, evidence of knowledge that appeared, flourished, and in many cases vanished, leaving us to puzzle over how they knew what they knew. These aren't just ruins, they're challenges thrown across millennia, daring us to figure out what the ancients understood that we've forgotten. If this journey through impossible architecture and inexplicable engineering left you wanting more, there are countless other mysteries waiting to be explored. The ancient world wasn't primitive. It was sophisticated in ways we're only beginning to recognize. What other secrets are hiding in plain sight, waiting for someone curious enough to ask the right questions?